Okay, so today we're going to learn about the neuromuscular junction or the neuromuscular transmission, like how the impulse or the action potential is transferred from the neuron to the muscle and the muscle contraction occurs. Okay, so for this we have to learn that the spinal cord has two horns, anterior horn and the posterior horn, and the motor neurons basically come out from the anterior horn and they go right through. Okay, so this junction between the motor neuron and the muscle is called the neuromuscular junction, and the gap between them is called the synaptic cleft or the neuromuscular gap. Okay, so the mitochondria of the motor neuron secretes acetyl-CoA, and ECF of the motor neuron secretes choline, and they both mix together to form acetylcholine, which is a neurotransmitter. Okay, and they are formed by acetylcholine transferase. Okay, so now there are a few vesicles called the synaptic vesicles, which come right through from the cell body of the motor neuron and come and settle down in the nerve ending of the motor neuron, and these are called synaptic vesicles. Okay, so the ACH is just loaded inside the synaptic vesicle and they are filled with the ACH or the acetylcholine. And now what happens is that when the synaptic vesicles are loaded, then the few channels open up, which are sodium channels, potassium channels, calcium channels. These open up. So let's draw the channels up. Yeah, like so. And there are other channels even, like sodium, calcium. Okay, so first what happens is the sodium channels open up and a sodium influx happens and the cell is loaded with sodium. Now, as a reaction, when the sodium is loaded inside the cell, the calcium channels even open up. So when the calcium channels are opening up, the cells are loaded with calcium, and there are a few calcium sensitive proteins present in the surface of the synaptic vesicle and the membrane of the nerve ending. The protein present in the surface of the synaptic vesicle are the synaptobravin. The proteins present in the nerve ending of the synaptic vesicle are syntaxin. So let's explain that in details. I'll just zoom up the view and explain that in another portion. Okay. So there are two vesicles, synaptobravin, present on the covering of the synaptic vesicle, and the syntaxin present in the nerve ending. Okay, so this is maybe the nerve ending or the membrane, the ending membrane of the nerve. This is the syntaxin, and suppose this circular thing is the synaptic vesicle. Synaptic vesicle, and the layer on the membrane covering up the synaptic vesicle is known as the synaptobravin. Okay, this black thick layer is called the synaptobravin. And this thing over here, as we all know, is called the syntaxin. Okay, so now the syntaxin dissolves the synaptobravin, reacting with the synaptobravin, and the acetylcholine is released. Okay, so the acetylcholine comes out and it goes to the muscle membrane, and at the muscle layer there are some pentameric proteins present, which are even known as nicotinic cholinergic receptors, because they are choline receptors as well as nicotine receptors. Okay, so these vesicles look like so. They are pentameric protein, so they have 5 proteins. Okay, so they look like this, and they are basically closed up, and the acetylcholine helps them to open up, and they are basically influxing sodium and potassium. So here goes the sodium inside the vesicle and coming down. This is actually a receptor. Okay, so as I told you, they are pentameric, so they have 5 units. Alpha. Okay, so there are 2 alphas, so 1 alpha and there is another alpha, beta, gamma and delta. Okay, so there are 5 proteins present: alpha, alpha, beta, gamma and delta. Okay, so let's go back to the diagram, and I'm just drawing that up roughly in here, and the influx is going to happen. Okay, so let's draw the influx up, like the sodium and potassium coming in and going out of the cell. Okay, so let's draw the influx, and then what happens is that the resting membrane potential is affected, and the potential becomes 0 millivolt from minus 80 millivolt after the influx of the channels, as the Na plus is entering, and obviously the potential is getting disrupted and the muscle junction is getting excited. So minus 80 millivolt to 0 millivolt is the takeover. Okay, so now this impulse or this depolarization traverses from the sides and goes to other sides of the muscle membrane. So let's go from this side and that side of the muscle membrane and draw it up. Here we go. It traverses all up on both the sides, and on the other side let's draw it up. So it doesn't only go up, it even goes down, and like it goes everywhere. The depolarization is going everywhere on the specific region of the muscle contraction, or on the region where the muscle should be contracted. And there are even other sodium channels. So when the depolarization goes on the other side, so these sodium channels even open up and sodium influx happens, and this process goes on and on, exciting all the sodium channels up and depolarizing most of the muscle as much as possible. Okay, so now what happens? The acetylcholine breaks up after its work is done and forms A plus CH, or acetyl-CoA. Plus choline. Okay, now these acetyl-CoA, what happens with these are eliminated, and these are acetylcholine esterase, which breaks this acetate and choline into the respective ones from the acetylcholine. Okay, so now the acetyl-CoA which is released is gone out from the body or eliminated. It may be used for other purposes and can be rapidly produced by mitochondria, so it doesn't need to be preserved. But the choline should be preserved because it is not easily produced, so the choline goes back to the ECF. And this is how the neuromuscular transmission takes place and the muscle contracts thereafter. Thanks for watching. I hope you like the video. And please comment, share and subscribe to my channel.